Hello guys, a quick refresher of the equation of a straight line. There are basically three ways, which are more than three, but let's say three ways of you can express the equation of a straight line. The first one will be the standard form, and this is just ax plus by equals c. The second one is the slope intercept form. I'm missing a t here. Intercept form. This is y equals mx plus b. And the third one will be the point slope form. And this is something like y minus y1 equals m that multiply x minus x1. Okay, first remember identifying whatever they are. The standard form, I can convert it actually in any of them. You can solve here for y, for example. If I solve here for y, then what you're getting is that y equals c minus ax, everything divided by b. So you can say that negative a over bx, I'm just reorganizing this, plus c over b. And then you get in a slope intercept form, where m is going to be equal to negative a over b. And b, I know there are two b's here, but this b refers to that, or to that, and this b, the y-intercept, is c over b. I should call this capital B, okay, like that. Now, the last one is point slope. You need 2 points or 1 point and the slope. Straight lines can be in this direction. That means that it's rising. If it's rising like that, the slope, which is called m, is positive. If it's coming like that, the slope is negative. And if it's not changing, horizontal line, for example, then the slope is 0. Also can be a vertical line, but if it's a vertical line, then the slope is indeterminate or infinite, some people say. How do you do this and how do you work with this? Let's say that you have a problem that requires that you calculate the equation of a straight line, and then you have, I don't know, find the equation of the straight line that passes through 2 points. If you have the equation of a line that passes, if this is the question, equation of a line that passes to 2 points, let's say that you have a point 1, and the point 1 is 1, 3, and then you have a point 2, and the point 2 is negative 4. This is the point 1, this is the point 2. So you can say this is x1, x2, y1, I'm sorry, and this is x2, y2. The first thing will be calculating the slope. A slope is always this amount, which is called rise, divided by this amount, which is called run. So the slope is rise over run. But in order to find this rise, whatever you do is that you take the second point, y2 minus y1, the y coordinate of the second point divided by x2 minus x1. So for this particular example, it will be 4 minus 3 divided by negative 2 minus 1. And in this case, you can calculate the slope. 4 minus 3 is 1, negative 2, negative 1 is negative 3, so negative 1 over third. This is the slope m. And now you can apply the point and slope and say y minus, this could be y1, x1, or y2, x2, any of the points. It can be, let's say that just for the sake of, I call this y1, and you can use it. You do it and you practice. But I can say, I can use this point if I want to. Y minus 4 has to be equal to the slope, negative 1/3, that multiplies x minus this point, and this point is -2. So if I solve for y, for example, then y will be, I pass this to the other side, right? Plus 4. And then you have -1/3 of x, and then you have negative times negative is positive, times negative is negative, 2 times 1/3 is 2/3, -2/3. And that will be the equation plus 4. And then of course I have to solve for this part, 4 minus 2/3, and then you can say that y is going to be equal to -1/3 of x, and then this is what? This is 12/3, 10/3, plus 10/3. And that will be the equation of the straight line. If I want to express this in standard form, let's say, I only have to multiply by 3 and put it exactly like you see it over there. But this is just a quick refresher, okay? Let me tell you how you're going to use this in statics and other engineering courses. You're going to find these type of loads, which are called distributed loads. And as part of your, I'm just trying to zoom this. Okay, good. You're going to have to find the equation of these distributed loads. Don't worry about that if you don't know what is that right now. But this is what you have to do. So you can use any of the shapes, any of the equations of the line. But the easiest way, in my opinion at least, is use the y equals mx plus b. Let's say that you want to calculate the first load, this load, and I want to calculate this equation. The slope is rise over run, but because it's in this way, it's going to be a negative. You don't need to know that, because you can say also y2 minus y1 divided by x2 minus x1 if you want to do it like that. And then you check the coordinates of this point. The coordinates of this point in x is 0. Let's assume that you put your axis here, x and y, for that load. So basically this point will be 0 in x, 3 in y. So that point will be 0, 3. And this other point here will be 6, 0. That's basically what you have. So if you want to calculate the slope is just y2 is 0 minus y1 is 3. So 0 minus 3 divided by x2 is 6, x1 is 0. And then this is going to be negative 3 over 6, which is basically negative 1/2. Or you can just say, okay, my slope is going to be negative because it goes in this way, and you do just rise over run 3 over 6. So my slope is going to be negative because it's coming in this direction, negative 3 over 6, which is negative 1/2. Once you have the slope, the other part that you have to recognize is the y-intercept. Y equals negative 1/2 x, slope times x, plus the y-intercept. And the y-intercept is just the point where the equation cuts the y-axis at the origin. And this point is 3. And that will be your equation for that load. Now let's try with the equation for this load. If you're working with this equation, you can put your axis of reference here. That's what you want to do, y and x. And then we need this equation. How do you get that equation? Very simple. Y equals mx plus b. Now, this load goes in an ascending way. That means that it's going to be a positive slope. What is the rise? 3. What is the run? 6. So your slope is going to be 3 over 6, which is 1/2, but it's positive because it's going in that way. And then the equation will be y equals the slope 1/2 of x plus the y-intercept. The y-intercept, remember, is the point where the line intersects the y-axis. In this case, is 0 because it's just exactly over the x-axis. So that will be the equation of this one. Believe it or not, this is one of the main errors that the students do when they find triangular loads in one direction or in the other direction. Let's say that you want to find out the direction of this load, the equation of this load. Same thing, y equals mx plus b. Now imagine this load, once again, you put this thing here, and you put this thing here. This is x, and this is y. But you know that when you have a horizontal line like this one, then your slope is 0. So basically the only thing that you need to know is the y-intercept, and the y-intercept is the height of this thing, which is w in this case. It could be any number. So y equals w. That would be the equation of that distributed load. There's another thing that we do after that, but for now, I'm just looking for the shape of the line. Now let's say that you want to calculate the equation of this one. Y-intercept form again. I put my axis here, I put my axis here, x and y. I can use 2 points if I want to. The first point will be 0 in x, 30 in y, and this point here will be 12 in x and 120 in y. Or I just see that in reality this is the rise, which is 120 minus 30. So my slope will be 130 minus 120 minus 30, 90, divided by 12. If you get too confused with that, use the point. So slope is y2, 120, minus y1, 30, divided by x2, 12, minus x1, 0, 90 over 12. And because it's going in this direction, raising, that means that this is going to be a positive slope. And then you can simplify this, divided by 3, divided by 3, or put a numerical value to that, 90 divided by 12, that's going to be 7.5, so your slope for this problem will be 7.5. But the equation, once again, mx plus b. B is the y-intercept, the point where the line intersects the y-axis, in this case 30. So it will be 7.5 times x plus 30. The good thing about this is that you can test it really quick. So if you have 7.5x plus 30, you can assign 0, for example. When x equals 0, y will be 30, which is this point. So it's correct. And when x equals 12, if I put 12 here, 7.5 times 12 plus 30, that will be 90 plus 30, 120, which is this value here. So in other words, this is the equation of that straight line. Please keep practicing reviewing this type of problems because you're going to face those in my class, in statistics class, in your class, by the way, not my class, because you are the one taking it. See you next video, guys.